I'm back in the UK in search of an answer to the question we were left with previously. What really happens to those waste materials that can't be recycled like for like? We've seen what can be done with materials like paper, aluminium, and PET plastics that can be processed through like-for-like recycling. But beyond this, we're left with those non-recyclable materials composed of mixed or contaminated waste from households or industrial production, such as contaminated soil, sand, sewage, or steel slags. In many countries, this type of waste is handled by sending it for incineration to generate energy, or simply to landfill, if that's not possible. So how can we turn this type of waste into something useful again? It's actually cement, and to produce it, you need raw materials and heat to create a thing called clinker. And what does clinker production have to do with non-recyclable waste? Well, I'm here in Stoke-on-Trent at the processing site with Andrew to find out. Andrew, what type of contaminated non-recyclable waste are you processing here?
The material behind us is called foundry sand. Starts its life as virgin quarried silica sand that metal foundries use to form moulds to enable them to cast metal pieces and parts for everyday industry.
Why is foundry sand considered a waste material?
When foundry sand reaches the end of its natural life, it ultimately has to be treated. Unfortunately, due to the nature of the material and how it loses its intrinsic properties, along with some of the acrylic binders and resins that they add to it to form moulds, it's really hard to recycle, so therefore it has to be treated appropriately.
How does recycling help solve the problem?
Ultimately, if we didn't recycle waste foundry sands, they would end up in an inert landfill. Unfortunately, you have to treat them very carefully and very precisely. So here, we crush, we screen, and we create a uniform product that ultimately can go back into the cement plant as an alternative raw material.
So we've got our finely filtered raw material from previously contaminated sand. So what happens next? I'm here with Andrew Latham at the GeoCycle site, and he's going to walk us through the next stage in this alternative raw materials journey. So what is clinker and how is it produced?
Clinker is made in our rotary kiln by combining all our raw materials together at very high temperatures, around about 1,450 degrees. This changes the chemical composition of these materials, which in turn turns it into clinker. And in essence, clinker is what makes cement cement.
So what happens when we inject the non-recyclable material into the kiln? What are the benefits of doing that?
So in our case with the foundry sand, which is a byproduct of the metal casting industry, is very similar in properties to our natural sand that we would normally use. So we can substitute it like for like. So this diverts it from landfill and reduces the environmental impact.
So by using non-recyclable materials as a substitute or alternative to raw materials, does that impact the quality of the cement at all?
Absolutely not. There are strict quality control and process testing and regimes in place to ensure that product quality is not affected in any way. In fact, this type of process has been used for over 50 years within the cement industry. In some cases, the materials that we're using as alternatives can enhance the final product.
This is playing a big part in more sustainable cement production as part of a circular economy. And if we look at the waste management hierarchy, we can see how even contaminated materials can be prevented from ending up in incineration and landfill. But this doesn't stop all non-recyclable materials from going to incineration and landfill because it's near impossible to recycle everything. So what happens to those materials that can't really be repurposed? On the final part of my journey, I traveled to Mexico to discover how the cement kiln is tackling one of the toughest modern challenges, the global microplastics problem.